Welcome to the first video lecture for Chapter 7. This lecture will cover impulse and momentum. Please follow along in section 7.1 in your textbook. When we looked at work, we said that you applied a force over some distance or displacement, you changed the energy of an object. This could have increased its height, changed its motion or speed, but you changed the energy. We will look at impulse as a force applied over a period of time. The force will change the motion, and it depends on how long that force acts for. Here you see the equation with the average force, that's with the bar above the F, and delta T, which means the change in time. The unit for impulse is a Newton second. We will look at the average force applied on an object over a period of time. This is because the force varies from when the two objects will come in contact with each other or whenever the two surfaces start touching. There will be some maximum force and there will be some minimum force. And that's why we will look at the average force. That's what the bar above the F denotes. Thinking back to Newton's first law, we remember that inertia is the resistance to a change in motion. Here, we have a mathematical quantity that describes inertia in motion. Momentum is inertia in motion. The momentum of an object is represented by P, and it is equal to the mass multiplied by the velocity of the object. Once again, momentum in P is equal to mass times the velocity that the object is traveling at. Momentum is a vector because velocity is also a vector. Impulse, a force applied over a time, causes a change in momentum. If you apply a force for some period of time to some mass, m, you cause a change in velocity. This is just a change in momentum, as written out below. You have the initial velocity and the final velocity for the same mass. Notice that the mass never changes. The other idea here is that for the same change in momentum, for example, a bowling ball being dropped to the ground and stopping, you can either have a large force applied over a short period of time. This would be for the bowling ball hitting a hard surface. Or you can have a smaller force over a much longer period of time. This would be, say, a bowling ball being dropped into a pool. Now, in each one of these cases, you have the same change in momentum, but the force applied is different. This is where we have a lot of safety applications for airbags and different things like that. Here are 3 review questions for this lecture. First, which has more momentum, a kid pedaling a bike or Brookline High School? Second, which takes more of an impulse, stopping a 2,000 kilogram boat going 10 meters per second in 10 seconds or stopping a 1,000 kilogram car going 20 meters per second in 1 second. Remember, impulse is the change in a momentum. And finally, which object, the car or the boat from the previous question, experiences a greater force? Why? Please make sure to follow along in your notebook, in your textbook, and complete your notebook for class today. Thank you very much, and I will see you in class tomorrow.